guys, so we are going to start a new chapter on chemical reactions. This is probably one of my favorite chapters because there are so many interesting things that go on with chemical reactions. We're going to do our best to try to bring you as much digitally as we can to these chemical reactions, these labs that we're going to be doing, these demos that we're going to be doing. A lot of fun. So hopefully you'll gain some kind of knowledge through those videos and through the lessons in which you're going to learn with me teaching. Pretty excited about this chapter. Looking forward to talking with you guys on Monday, and hopefully you'll understand where we're going with this next part. So the first thing we're going to start off with in chemical reactions are, how do you know when a reaction has taken place? Okay, so what makes a reaction, right? So how do you know something's changed? Remember, chemical change is something that has to change. So there are indicators that you can identify as to how they're going to change. Okay, so for example, emission of light or heat. Okay, so you can feel the reaction. All right, so when you are lighting a campfire, you see the light, right? But you also feel the heat. So that's an endothermic, but that's a type of emission of light or heat. Okay, then we have formation of a gas. Okay, a lot of different ways a gas can form. A lot of times you don't even know a gas is forming because you don't see it. Okay, but when you can see that a gas or smoke or any kind of gas is being formed, sometimes you can even smell it. Those are examples. Sometimes you see when you put two things together, it starts bubbling up. Okay, that's a reaction. Now you have to know the difference. Just because you're boiling something with bubbles as opposed to something else bubbling, those aren't the same things. Boiling is a physical change. You're just changing the state of matter. When you are creating a chemical reaction, you're taking two substances that are at the room temperature, pouring them together, and they'll start bubbling. Okay? Formation of a precipitate. So if I had two liquids and I just pour them into each other, and ooh, boom, I get a solid forming out of that. You'll see like a solid or a color change of some kind of thick substance. That's called a precipitate, which basically means it's a solid coming out of solution. Okay? So that's a form of chemical change, but it's a solid coming from two liquids. Okay, so that's why they call it a precipitate. And then finally, a color change. Now, I'm not talking about saying, oh, this mask is red and black. That's not a color change. A color change is if I had two clear liquids and all of a sudden, boom, I mix them together and they're blue. That's a color change. If I have blonde hair and all of a sudden I dye my hair purple, that's a color change, right? So those are examples of chemical changes because you're radically changing the color of the substance. All right? The last one is emission of odor. That's a bad one. So have you ever had something in your fridge and you let it go way too long and then you open up the container and you're like, oh, that's awful, terrible smell. That's odor. That's emission of odor. You have now had a chemical change going on in your fridge and you got to get rid of that quickly, right? And then you want to take that garbage out immediately because it's terrible. So rotting food is actually an emission of odor, and which the bacteria is forming. So chemical changes are actually happening within that food item. Okay? All right. Now, when you have emission of light or heat, what are some examples of those? Okay? So all chemical reactions are accompanied by a chemical change in energy. Okay? We have exothermic. Okay? When you have exothermic, reactions release energy. So I just talked to you about a campfire, right? So if you put some logs on there, you light the campfire, you feel it burning, that is an example of an exothermic reaction. In the Google Meet last week, I showed you a video of me taking bubbles and lighting those bubbles on fire. Well, if you were in here, you would have felt that heat coming off of those methane bubbles. That was exothermic, okay? Now, endothermic, when you were a kid, did you ever get a bump or a bruise and they took that bag and they broke it, and then when they broke that bag, all of a sudden it felt like an ice pack, it got really, really cold, and you put it on your arm? That's actually endothermic, in which the energy is being absorbed. The heat from the surroundings is being absorbed, giving it energy, and then you feel the cold substance that's that of the two chemicals that have mixed together. So I don't know if you knew that or not. The whole purpose of you breaking that bag is because there's actually two chemicals in there, and when mixed together, they form a chemical reaction. They pull in the surrounding heat. The heat helps the reaction take place, and then it releases energy in the form of cool air, okay? So it feels cold because it's absorbing all that energy. So to us, it feels cold, although it's called an endothermic reaction because of the heat that it's pulling in, okay? Now, enthalpy is positive and energy coming into the system, all right? Now, let's look at the next one, a gas being produced. So when you have a gas produced, usually it's carbon dioxide or hydrogen gas that's produced. So if I take a reaction, so if you're at home and you have baking soda and you pour baking soda into a beaker and then you decide to add some vinegar, you're gonna see a lot of bubbling going on, right? The bubbling is mean a gas is being produced, okay? If this gas is being produced, you'll see the bubbles forming, and that's actually in the form of carbon dioxide gas. You can also mix zinc and hydrochloric acid together and produce hydrogen gas, which, by the way, is highly flammable, okay? Now, like I told you before, when you have a precipitate being formed, okay? So you're pouring two liquids together, and as you can see right here with this picture, a yellow solid is forming, insoluble, okay? So an insoluble solid is forming from the two liquids combining. And this solid, this right here is your precipitate, okay? They do not go back into solution. So once that precipitate is formed, it's there. You can actually use something called a centrifuge, which you stick them all in if you have precipitates, and you can stick them in the centrifuge and it spins rapidly, really fast, and it actually separates the solid from the liquid. Okay? Color change, right? An unexpected color change accompanies many chemical reactions. So, bumper, if you have an iron bumper, right? What happens if it oxidizes? That's where you get rust, okay? So rust forms from the oxygen in the air bonding to the iron, and it oxidizes and produces iron oxide, okay? So this right here is nitrogen dioxide, okay? So nitric acid is reacting with copper in this reaction to produce copper 2 nitrate. So if you take a penny and you drop it in nitric acid, it's actually going to dissolve the copper. The copper is going to go into solution and make copper 2 nitrate, and then you're going to be left with nitrogen dioxide, which is a gas. All right, here's your odor produced, right? When you have smelly shoes or smelly boots when they get wet, you want to add substances in there or spray inside your shoes because they smell terrible, right? So odor produced. So odor change can take place in a chemical reaction, right? Now, all chemical reactions have two parts, okay? You have your reactants. These are what start the reaction, okay? They're usually on the left side of the reaction, and then you have your products on the right side of the reaction, okay? Those are the substances that you end up with. A lot of people always use this term where they think, oh, it has to be adding together to be reactants, and then they mix it up. So everything on the left side is what's reacting, okay? Everything on the right side is what you're producing. That's why when you see a chemical reaction, you'll see the arrow pointing this way. The reactants form the products. So that's why the arrow is pointing in that direction, because you're forming something, okay? So it's always creating something new when you have a product, okay? And that's what I was talking about with the arrow. See how it's pointing to the products? The reactants are forming the products, okay? Now let's talk about describing a chemical reaction. So we're going to be working on today, that's one of the main focuses we're going to be working on, is if you have a sentence written, how do I take that sentence and turn it into a word equation, okay? So we're going to build this in steps. Each day we're going to build another part of how we write the chemical reaction. So all we're going to focus on today is taking the words in the middle and changing them into making it look like a reaction. Now we're not going to use formulas or charges or anything like that today. We're just focusing on taking the words, adding your addition and yield signs, and whether or not it's a gas or aqueous or different things like that. So that's how we're going to do it. We're just going to take the sentence and form the word equation. So in this example, copper reacts with. So if you notice this term reacts with, okay, that's the same thing as saying it adds, okay? Chlorine, so it reacts with chlorine to form. That part, that to form part, is where you would see the arrow, okay? The arrow, so the reactants are forming into your products. So copper reacts with chlorine to form copper 2 2 chloride. So we're going to keep this in word form, but we're just going to change it and add our pluses and our yield signs. Okay, so right here, copper plus, see that reacts with, becomes a plus, chlorine, 2 form becomes the arrow, copper 2 chloride. So that's what we're going to be practicing today. We're going to be taking these sentences and we're going to be changing them into word equations. Okay? Now, there are different symbols that we use in our reactions. So S means that after the formula, it's a solid. So if it says solid copper, you would write Cu with an S here. If it tells you that it's gaseous hydrogen or hydrogen gas, you'll put a G for gas. If it says it's liquid water or liquid H2O, okay, liquid water is going to be H2O and you're going to put an L for liquid. And then a lot of times it'll say dissolved in water or aqueous solution of, okay? If it's dissolved in water or aqueous solution of, you have the formula or the word and you would put AQ followed. Okay? Now, we have symbols that are used in reactions. So if it's one going this way and one going that way, it's a reversible reaction. We're not really going to have any that we really talk about in terms of reversible reactions. Then we have a yield sign, and it has this little triangle above it. That means heat is being added to the reaction. And then sometimes we have these little elements, okay, that are above the arrow. And this is a catalyst. What that means, what a catalyst is, a lot of times if you mix 2 substances together, they're just going to sit there for a really, really, really long time and take a long time to react. So sometimes we add a substance in there that has nothing to do with the reaction and doesn't really affect the reaction at all, but it allows the reaction to go forward quickly, okay? So it'll actually react a lot quicker than it would normally if you add this catalyst in there, okay? So it speeds up the reaction, okay? So once again, that triangle, it shows that heat is supplied to the reaction. Catalyst is used to indicate a catalyst, and it's used to, in this case, platinum, okay? Now here's a summary of all of what I just covered, okay? And that'll be in the notes. Okay, so what is a catalyst? It's a substance that speeds up a reaction without being changed by the reaction, okay? If you're looking at biology, enzymes are biological or protein catalysts, okay? All right, so we're going to stop there, and you guys are going to be working on some examples. Now later, there'll be a second video that we're going to attach where I'm just going to do a couple of sentences where I show you how to put those into word equations. It's just a little bit easier to do that on the document cam than it is to do it up here, demonstrating it on the board. So there is going to be a video following this that'll also help you with some examples, and then you will have an assignment following this in which you're going to have to turn into Google Classroom, okay? Well, I'll see you later when we start talking about how to take these word equations and change them into formula equations, okay? So that's going to be the next thing we do. See you later.